Deep in the heart of the factory, we uncover the secrets of how this common staple is extracted from the Earth's bounty. From the moment the sugar beets arrive at the factory, they undergo a rigorous transformation, culminating in the pure white crystals seen here. The sugar beet undergoes washing, slicing, and diffusion before the clear juice is finally crystallized into these pure sucrose granules.
The sugar beet, seen here in macro detail, is the fundamental source ingredient. These beets are carefully cultivated before being transported for processing.
While much of the world gets its sugar from cane grown in the tropics, in these temperate climates, the sugar beet is the star. But how does this root vegetable become this crystalline sugar? That's what we're here to find out. It all begins here, in the fertile soil of the spring planting season. The mechanical seeder carefully deposits pelletized seeds into the rich soil, spacing them perfectly for optimal growth. The process starts with the careful placement of the sugar beet seeds, coated in blue for protection. The journey of sugar begins here, in the fertile soil where the sugar beet thrives. The sugar beet is a marvel of nature. Using photosynthesis, the plant stores sucrose in this large white taproot, which is now ready for harvest. The sugar beet's primary function is to store high concentrations of sucrose, synthesized in the leaves, within its The arrival of autumn signals harvest time across these vast fields. The sugar beets are ready to be processed. Welcome to How It's Made, Sugar from Sugar Beets. The massive steel shares plunge deep into the earth, leveraging the sugar-rich beets from the dark soil. The beets are first subjected to a series of spiral rollers. As they rotate, the heavy clumps of mud are knocked loose.
Pulling a sugar beet by hand requires significant effort. This manual process is a stark contrast to the efficiency of modern mechanical harvesting.
The massive harvester efficiently pulls the beets from the rich soil, immediately separating the leafy tops before sending the roots up the conveyor.
These massive piles, known as clamps, serve as temporary storage before the beets are transported to the factory. To ensure the quality of the sugar, the beets are stored under these protective covers, which shield them from frost and moisture until processing begins. After harvest, the sugar beets are stored in massive piles called clamps. This red cleaner loader machine will now separate the beets from the dirt and rocks. This massive cleaner loader efficiently scoops the freshly harvested.
Trucks laden with freshly harvested sugar beets arrive continuously at the factory, ready for the extraction process to begin.
Once the beets arrive from the fields, the trucks must be precisely weighed before the refining process can begin. The first step is quality control. A probe extracts a sample from the truck, which is then tested for its sugar content back at the lab. The automated system mashes the sample, then uses a refractometer to test the sugar levels, a critical step in the extraction process. The process begins as the freshly harvested sugar beets arrive at the factory and are dumped into these massive concrete hoppers.
At the receiving station, high-pressure water jets blast the freshly harvested beets, cleaning away the soil and moving them into the factory channels.
The sugar beets are vigorously washed as they travel through the flumes, carried by the powerful current directly into the heart of the processing facility. Mechanical rakes continuously lift the floating leaves and grass from the water, ensuring only the clean beets move forward.
The sugar beets are first thoroughly washed in massive rotating drums to remove any dirt and debris before the extraction process begins.
Inside the washer, the beets are violently agitated, rubbing against each other under powerful water jets until they are completely clean.
Here at the inspection stage, factory workers carefully monitor the flow, removing any beets that don't meet the high-quality standards.
The unique zigzag pattern of these knives is precisely engineered to maximize the surface area of the beet slices. The washed beets are fed into these massive slicers. Inside, high-speed blades reduce them to...
After washing, the beets are sent to the slicer, which cuts them into thin, spaghetti-like strips called cassettes.
Next, the cassettes are vigorously pumped into the bottom of the diffusion tower, the first step in extracting the raw sugar.
This is where the crucial process of osmosis begins. As the hot water penetrates the cell membranes, the crystalline sugar molecules, seen here in green, are rapidly drawn out through the process of diffusion. After the sugar is extracted, the remaining beet pulp, now sugar-free, is expelled from the diffuser to be used as animal feed.
To maximize efficiency, the pulp enters the screw press, where intense pressure extracts the remaining water before the drying process begins.
The dried pulp is then compressed through a pelletizing machine, forming dense cylinders. These pellets are highly...
This dark, raw juice is the result of the diffusion process, where hot water has pulled the sugar from the beet shreds. The amber liquid, fresh from the diffuser, is rich in sugar but also contains pulp and other impurities that must be filtered out.
The massive vertical kiln burns limestone at high temperatures, producing the lime and carbon dioxide essential. Here, limestone rocks and coke fuel are carefully mixed on the conveyor. They are then fed into this kiln to produce the lime necessary for the...
Burnt lime is introduced to water in the slaking tank, creating a vigorous reaction that produces this white lime milk.
The lime kiln is essential, as the carbon dioxide it produces is used in the carbonation process to purify the sugar.
Next, the raw juice is transferred to large stainless steel reactors for purification. Here, a mixture of lotions.
In the carbonation tank, we introduce calcium hydroxide, or milk of lime, to the raw juice. Then,
the introduced chalk crystals actively trap the non-sugar particles. This creates larger, heavier clumps through flocculation. The muddy diffusion juice, as it's called, is now pumped into these massive filter presses to remove the remaining solids. Here, the raw juice is pumped into large filter presses, which separate the clear sugar liquid from the dark, non-sugar impurities.
Once separated by the filter press, the lime mud is transported away. This substance is rich in nutrients and makes excellent agricultural fertilizer.
The clear, golden yellow liquid flowing rapidly here is known as thin juice.
Steam is introduced into the first effect, heating the sugar beet juice. As the water evaporates, the vapor is used to heat the next stage in the series.
As the steam heats the tubes, the juice begins to boil vigorously. This evaporation process removes water. To save energy, the vapor from the first tank is used to heat the second, creating a cascade effect that efficiently concentrates the sugar solution.
In the massive evaporator tanks, the purified juice is boiled. The water content flashes into steam.
Here we take a sample of the concentrated sugar solution. This dark golden syrup is nearly pure sucrose, ready for crystallization. These enormous tanks can hold the concentrated sugar solution for months, ensuring a year-round supply to the crystallizers.
On the vacuum pan floor, the syrup is boiled at a lower temperature. The worker monitors the gauges closely as the sugar begins to crystallize. By creating a vacuum inside the pan, the boiling point of the sugar solution is significantly lowered. This prevents the sugar from burning.
The concentrated solution is then seeded. Watch closely as the individual sugar molecules lock into place.
Here in the control room, the operator oversees the vacuum pans, making minute adjustments to the temperature and pressure to ensure the crystals form correctly. Next, the raw sugar, still moist from the extraction process, is moved to large industrial dryers for the final stage.
The syrup is boiled under vacuum, causing sugar crystals to form. This thick, bubbling mixture of crystals and syrup is known as masequite.
The vacuum pan is emptied through a large valve. The resulting hot masequite, a thick mixture of crystals and syrup. The next step involves these powerful centrifuges. The rapid spinning separates the white sugar crystals from the dark molasses.
The next step involves refinement. The knob is dropped into intricately spectral spinning basket where the synth spill.
A spray of hot water washes the final film of syrup off the crystals, which turn pure white.
The reject chute ensures that only the finest crystals move forward. These larger, impure clumps are recycled back into
the crystallized sugar, now 99% pure, is fed into large, rotating stainless steel drums for the final drying process.
Here, the crystallized sugar is dried in large, rotating drums. Paddles lift the sugar, dropping it through currents of hot air to remove the remaining moisture.
Here, Cool, pressurized air is blown over the crystals to prevent caking and ensure a perfect, dry consistency.
Exiting the drum, the moisture content is meticulously reduced to less than 1%, resulting in these perfectly dry, sparkling crystals.
To guarantee a consistent product, the sugar is rapidly shaken through vibrating screens, separating the fine granules from the coarser ones. Air quality is paramount here. These powerful vacuum systems remove fine sugar dust, which can be highly explosive, ensuring worker safety.
From the processing plant, the finished sugar travels up this enclosed conveyor bridge, moving rapidly towards the massive storage silos. These massive concrete silos can hold thousands of tons of sugar beets, ensuring a steady supply for the factory year-round.
The crystallized sugar is transported via conveyor belt into massive silos for storage before the final stages of production.
To ensure the highest quality, the sugar is tested rigorously. This colorimeter measures the exact purity against strict industry standards.
Here in the lab, samples are dissolved in water to ensure perfect clarity and purity.
The refined sugar is now ready for packaging. Here, massive rolls of paper are rapidly folded into precise 1-kilogram bags.
The bags are then rapidly transferred to the sealing station, where a precise application of hot glue secures the fold.
As the bags move rapidly down the line, an inkjet printer applies a precise date and lot code to ensure traceability.
As part of the sugar refining process, these bags must meet strict weight standards. This machine automatically rejects any that are underweight.
Once packaged, the bags are grouped together and move through a heat tunnel, creating a tight, protective shrink-wrap seal for distribution. After crystallization, the sugar is bundled and sent through the heat tunnel, creating a secure, weatherproof seal for transport.
To protect the refined sugar, each pallet is securely wrapped in several layers of tight plastic film by the automated stretch wrapper.
Once crystallized, the sugar is dried, packaged, and prepared for shipment. The finished pallets are then moved to the warehouse for distribution.
The purified white sugar cascades down the chute into these massive industrial containers, each capable of holding a full ton.
The crystal clear liquid sugar, now purified, is pumped into tanker trucks at high pressure, ready for distribution.
Next, the refined sugar is sent to the cubing machine. Here, high pressure presses the moist crystals into uniform shapes before they are dried.
The crystallized sugar, now pressed into cubes, is carried by the conveyor belt into these massive drying ovens.
After crystallization and drying, the pure white sugar is formed into cubes. This automated system then packages the cubes with pinpoint accuracy.
Once the crystals are formed, they are ground down by these massive high-speed mills, transforming.
To prevent caking, a small amount of cornstarch is added to the refined sugar crystals inside these large industrial mixers. To create brown sugar, a specific amount of dark molasses is introduced to the white crystals in the mixing screw.
The refined sugar is then crystallized. Here we see the sticky, moist brown sugar cast.
Utilizing these massive distillation columns, the remaining molasses is processed into bioethanol, ensuring a highly efficient, zero-waste production cycle.
In these massive stainless steel vessels, the molasses is inoculated with yeast, kicking off the crucial fermentation stage to produce alcohol.
Inside the factory, the purification process begins. These massive distillation columns separate.
The ethanol, a valuable co-product of the sugar refining process, is carefully loaded into tanker trucks for transport. Water stewardship is crucial. The used process water enters these vast aeration ponds where mechanical bubblers begin the purification and recycling cycle.
The factory treats all processed water on site, ensuring that only crystal clear, purified water is returned safely to the river.
Inside the central control room, the entire sugar extraction process is meticulously monitored by advanced SCADA systems.
The modern sugar factory operates 24 hours a day during the campaign. This highly automated process requires constant monitoring by skilled workers.
This facility operates 24 hours a day, transforming humble sugar beets into the sugar we use every day. This facility alone processes thousands of tons of sugar beets annually, which are then exported through a sophisticated
The journey ends here, as the granulated pure beet sugar is packaged and delivered to stores across the country, ready for your table.
The resulting pure white sucrose is then carefully measured, often destined for baked goods where it is mixed with flour.
From the field to the factory, the journey ends with the perfect sugar cube, ready to sweeten your morning coffee.
Deeply rooted in the earth, the sugar beet is carefully extracted, ready for its transformation at the factory. Deep within this massive facility, the journey of the sugar beet begins, transforming the humble root into the sugar crystals that we know. Once the concentrated syrup reaches the crystallization stage, the transformation is rapid. Within moments,
After a meticulous crystallization process, the sugar is ready. This is raffinade, the highest quality white.
The sugar refining process transforms the humble sugar beet into the sparkling white crystals you see here, ready for packaging.
These are the end products of a complex process: pure white icing sugar and the distinct, darker crystals of brown sugar. And so, the journey from humble sugar beet to these sparkling white crystals is complete. How it's made. Sugar from sugar beets.